Hello everyone. Today's topic is electron configuration. Now electron configuration shows the total number of electrons that an element has. And there are different ways of doing that. So the first way is when you actually show the orbitals and show how the electrons are in those orbitals. So let's look at nitrogen as our example. Nitrogen has a total of 7 electrons. And the only orbitals available in there are the 1s, the 2s, and the 2p. And because he has 7, let's start filling them up. So 2 of them will go into the 1s, because if you recall, each individual orbital can hold up to 2 electrons. So we put the first 2 in the first s, the next 2 in the second s, and we spread these last 3 out because those orbitals have the exact same energy. Electrons love to fill the lowest energy orbitals first, but because these have the exact same energy, they will spread out because it minimizes repulsion. So when using this type of notation, again, observe how not every single electron, not every single orbital has 2 electrons in it. And again, it's because this reduces repulsion. Now again, each orbital holds 2 electrons, but this example here, it's the d orbitals, the 5 d orbitals that we have, and let's say we have the 5 electrons. Again, those 5 electrons are spread out because it minimizes the repulsion between them. If we were to have a 6th electron in this case, then that last electron will actually end up coming here, right? Once each orbital has the 1 electron, then we can start adding 2. So we had 7 electrons, 8 electrons, 9 electrons, and 10 electrons, right? So you cannot start pairing them up unless each orbital has 1 electron. Now let's go to the second way of doing it. Instead of writing out each orbital with the lines and putting the electrons in there, what we could do is just list the name of the orbital and put the number of how many electrons it has. So say we have 2 electrons in the 1s orbital. Instead of doing our usual orbital with the 2 electrons showing, 1 up and 1 down, we could just say 1s2, right? Because we're at the 1s and we have a total of 2 electrons. So 1s and the total of electrons. Let's go back to nitrogen. Guess what we had? And let's rewrite that to our new way of doing the electron configuration. So we say 1s2, there are 2 electrons in the 1s, 2s2, 2 electrons, and 2p, how many electrons do we have there? 1, 2, 3. So 2p3. Let's do one more. Let's try chlorine. So this is the electron configuration for chlorine. All of these, right? So let's rewrite that, and we get 1s2, 2s2, 2p6, 3s2, and then we have 5 electrons in the 3p, so 3p5. This makes it a lot simpler to write your electron configuration and a lot faster. But what do we have an element, say cesium? Cesium goes all the way up to the 6s orbital, so it will take a while to get there. So instead of using the configuration we used up here for nitrogen and chlorine, we are going to use the noble gas configuration, and this is a lot faster. So to do this, you have to look at the noble gas before the element in question, and because we're talking about cesium, the noble gas right before cesium, if you look at your periodic table, it's xenon. Xenon. So this is our noble gas notation. So we say that cesium, right? We put brackets around the noble gas, in this case xenon, and then we write the rest. By doing this, xenon actually takes care of every single orbital leading up to the 5p and then the 6 electrons that it has. Meaning that all we have to do is write whatever is left for cesium. So let's go back to the chlorine example. Right? This is chlorine, the way we wrote it up there. 1s2, 2s2, 2p6, 3s2, and 3p5. If we were to use a noble gas notation, neon is the noble gas before chlorine, so you put brackets around it, and then we rewrite the rest. So neon, 3s2, 3p5. This neon here takes care of the 1s2, 2s2, and 2p6, because that would be the notation for neon. And all we would have to do left is write whatever else is left that will give us chlorine. And this is a way to do electron configuration. Thanks for watching, and I hope this helps.